Welcome to the Contractors Institute. This slide is being narrated. If you cannot hear a voice, check your speakers and system requirements. If it still doesn't work, please call us at 1-877-LICENSE for additional tech support. My name is Richard Elsey, and I'll be the one hosting this module for you. Basic Mathematics, a real fun and exciting course, but we're going to see if we can have a little fun with it. Here's all the course information and all the legalities to go along with it, that we have our numbers down there, and okay. So go ahead and take a look at that. Okay, and then forward on. Now this learning module is structured to provide an overview of the general business or technical information applicable to the construction industry. It is not intended to be substituted for specific engineering, technical, business, or legal advice from the industry professionals. The Contractors Institute does not assure the accuracy of any statement or examples contained herein, nor shall be responsible for any errors or omissions that might be found in or excluded from this material. If you have any questions about the subject matter or wish to report any Scribner's errors, please email us at instructor@contractorsinstitute.com and report any copyright theft to theft@contractorsinstitute.com. The Contractors Institute vigorously enforces copyright infringement. All information is confidential and compensation is provided. Okay, copyright 71 to 2023, Contractors Institute. Now, this module is about basic problem solving and blueprint reading. Everything has a step to it. So the first thing we're going to do is get all the mathematics out of the way so everyone understands what we're talking about, when we do it. So when we jump into the other problems, everyone already knows and understands. So basic blueprint solving and blueprint reading. How exciting is that? Now, this is the front page of our plan set. Now, something I want to get you to notice here. Notice how these pages are labeled, our civil drawings. C01, architectural drawings, A01, plumbing, P01, electrical, E01, mechanical, M01, and so on. So by looking at the way the pages are numbered in any plan set, we can always tell which set of plans we're in. Are we in the civil series? Are we in the architectural series? But where? Okay, what are we supposed to be in? So this is what we're going to use to go through the course. And again, if you have any questions, stop and ask. PEMDAS. Now this is going to go back, let's just say a couple of years for some of you. Now, way back, at some time in your schooling, either elementary or middle school, you were taught how to solve an equation. And someone said, please excuse my dear Aunt Sally. Now, what that was a method to organize the numbers for myself and to solve any equation. Please excuse my dear Aunt Sally. So the first thing I always do whenever I see an equation is I solve what's inside the parenthesis first. I even read this as 8 plus the answer of 6 times 6. Well, 6 times 6 would be 36. Then 8 plus 36 then is 44. Then we have the exponents are solved next. Now this is 8 squared or 8 to the second power, which means the same thing. Anytime you see this, just take the number 8 and multiply it by itself, or any number times itself is 8 squared. You're creating a square, equal sides. So 8 squared would be 8 times 8, which is 64. What you have to be concerned about is when you get in a hurry, you'll make basic stupid mistakes, believe it or not. And it's real easy to see those exponents and, oh yeah, that's 8. 8 times 2 is 16, and miss it and go on. You don't even know you missed it. So be careful whenever you're doing this. Now, the square root of a number is just the opposite of that. If I told you you had 8 square feet of area, and I want to know what one side of the square is, all you have to do is push the 8 on your calculator and then press the square root key. The square root key will unsquare the number. So what number times itself equals 8? Once we do that, it tells me that's 2.828. 2.828 times 2.828 is 8. So that would be one side of the square. Once we do our exponents, then we do any multiplication we may have. We look at the equation, where can we multiply? This little x to us means it's a multiplication symbol. The little dot represents a multiplication symbol. And whenever you have a number set next to a parenthesis, that's understood to say 12 times 3. Well, look, all of them is 12 times 3. So no matter how you do it mathematically, you come up with the same answer, 36. Okay. The next thing we want to look at is a symbol set next to a letter squared. That's pi r squared. Area of a circle, that's right. Now the pi, 3.14, is what we need to remember about that. So it's pi times the radius squared. So pi times the radius times the radius. So what we need to remember about pi, the symbol of pi, in decimal form it's 3.14. That's all we have to remember. We don't have to remember it any more decimal points than that. Once we do that, then we do any division we have. 12 divided by 3, the division symbol. 12/3, that's considered a division symbol. And this one, if you remember, is the numerator divided by its denominator. That's a division symbol, okay, that line. And again, no matter how you choose to do your division, it's answer 4. So who really cares on how you come up with the answer of 4 as long as you get there? Okay. And the last thing we do in an equation, we do any addition, and then we do our subtraction last. Now, these brackets right here means to subtract a number from the other, sort of like a negative. Okay, so whenever we see a number inside a set of brackets, it means to subtract the number from the others, is all it means. Now let's look at a general thought process for this. Now, it's not hard, but I want to make sure everyone understands this. Visualize your takeoff. Now, if I would come to you and said, we got a room that's 20 foot by 10 foot. I want to calculate the perimeter of the room, or the baseboard length. I would just go around the room and add up all the dimensions. 20 plus 10 plus 20 plus 10, and that would give me 60 linear feet. Well, I would need 60 linear feet of trim boards to go all the way around the room. Now, the other thing I would ask you is your area of the room. Carpet area, surface area, painted area. How many square feet of carpet do I need? Well, that's 2 dimensions. Well, if I take 20 foot and multiply by 10 foot, that's going to give me 200 square feet of area. That's the square foot of carpet or square feet of painted area. And then the last one I have is cubic or volume, 3-dimensional. Now I know it's length times width, that's 200 square feet of area, but if I popped the depth in there and said, well, that depth is going to be 2 feet deep. Now you can call it a depth, you can call it a height, you can call it a thickness. It really doesn't matter what you want to call that third dimension. The important thing is, it's a third dimension. So an area calculation, no matter what the shape is, any area times a third dimension, depth, height, or thickness, is going to give you cubic or volume. And if this is 2 foot deep, it's going to be a 20 foot by 10 foot, that's 200 square foot area, multiplied by the 2 foot deep, that's 400 cubic feet of volume. Okay, 400 cubic feet there. So we have linear feet, okay, length, then we have square feet, area, and then we have cubic feet, which is volume. Okay. Now, I hope everyone pretty much knows this in the construction industry by now. If not, I just taught you something new. Now I'm going to teach you something new again. How to read an inch. Now, I know most of you can read an inch. And this is an inch broken down into sixteenths. You know, in construction, as long as we can get within 1/16 of an inch, we're okay. Now, if I need to get tighter than that, I can break it down into 30/2 of an inch. Or I could get even tighter and break it down into 64ths of an inch. Oh, why? We don't need to do that. 1/16 is good enough for us. So I have 1/16 all the way to 16/16, which is 1 inch. Okay. Now the big marks are all in 1/8 of an inch. 1/8, 2/8, 3/8, 4/8, 5/8, and then we reduce it to its lowest form. And I hope everyone understands that 1/4 is 2/8 or 4/16. It's all the same thing, just reduced. Okay. So all we have to be is within a 1/16 of an answer increment. 1/16. And they're never going to hold us that close. I mean, that is pretty close. So, and keep in mind, and most of you know this without even touching a calculator. 1 divided by 4 is 0.25. That's 1/4 of an inch. That's how we convert a fraction, numerator divided by its denominator. 1 divided by 2 is 0.5 inches. And then 3/4, without touching your calculator, that's 0.75 inches. I don't know why that did that, but who knows. So anyway, we know those without even touching anything. 0.25, 0.5, and 0.75. And then hopefully everyone can read an inch. Stop making fun of the people out on the job site and train them. Teach them how to read a tape. Come on, you're the one that's going to look like an idiot. It's not the labor out there. It's the employee when they start cutting all your boards wrong. Okay. So, feet and inches. Look, we can't mix 2 units. It doesn't even make any sense. So, whenever we have feet, we're going to keep it with feet. When we have inches, we'll keep them with inches. But I went to the whole units here. Everyone can tell a foot, and everyone knows what a foot's 12-inch increments. But mathematically, think about what it takes to convert a foot to inches. We have to multiply by 12. Anytime you take a reading in feet and multiply that by 12, that's going to convert it to inches for you. Now, anytime you have inches, if you have inches and you want to convert that to feet, you divide it by 12. So that's the only thing you need to remember is feet times 12 gives us inches, and inches divided by 12 converts it to feet. Okay, go back to the whole units if you get lost at the test, or when you're doing this and you get lost. Go back to the whole units. Think, well, 12 inches, what do I do to that to give me 1 foot? Okay, divided by 12. Now this is a fraction, a little bit harder because we have to take first and get rid of the fraction. Most standard calculators, I cannot plug a fraction into it, so I have to convert it. I do that by taking 1 dividing it by 2. 1 divided by 2 is 0.5. That's 0.5 inches. Still in inches, it's just a fraction to a decimal equivalent now. I still need to divide that by 12, and that would tell me a ½ inch is 0.0416. Okay, 0.0416 feet and a ½ an inch is the same measurement. Two different readings. It's like saying 12 inches is 1 foot. Same reading. So when we look at the decimal equivalence right here, again, we take the numerator and divide it by its denominator. The numerator divided by its denominator will convert the decimal into a fraction. So 3/4 of an inch, 3 divided by the 4, is 0.75 to you. And yeah, most of you know that. Well, 3/8, that's 3 divided by the 8, 0.375 inches. A 16th is simply 1 divided by 16. 1 divided by 16 is 0.0625 inches. See, every one of those is still in inches now. We haven't converted them to feet because we'd have to divide by 12. We just simply converted the fraction into a decimal equivalent. It's still in inches though. So we just said we'd take 3 inches and divide that by 12, and that would tell me what part of a foot it is. 3 inches, look at it, it's 1/4 of a foot. Now 6 inches, that's ½ a foot, 0.5 feet. 6 inches divided by 12 is 0.5. 9 inches divided by 12 is 0.75 feet. It's 3/4 of a foot. It is. Okay, so anytime we want inches converted into feet, all we do is divide it by 12. Inches divided by 12 converts it to feet. So if I have 4½ inches, now geez, I just said just divide it by 12 and that'll give you feet, but wait a minute, I can't. Unless I have a Construction Master type calculator, I can't plug a fraction into it. So I have to convert the fraction again first. And I do that, numerator divided by the denominator, 1 divided by 2. And again, that's 0.5. Now I can plug that into any standard calculator that I have. 4.5 divided by 12 is 0.375 feet. Okay, now it's part of a foot. Same measurement, 4½ inches, just now it's in feet. So we always take our inches and divide it by 12 to convert it to feet. So 3 inches divided by 12 is 0.25 of a foot. It's 1/4 of a foot. 4 inches divided by 12 is 0.33 feet. That's 1/3 of a foot. If you think about it, it is. 6 inches divided by 12 is 0.5 feet, ½ a foot. And 8 inches divided by 12 is 0.67 feet. That's 2/3 of a foot. And 9 inches divided by 12 is 0.75, which is 3/4 of a foot. Now I'm going to look down at that 1/8 of an inch down there. Well, that's not even a whole inch. That's only part of an inch. That's right. What part of an inch is it? Put it in a decimal equivalent of an inch. 1 divided by the 8. Well, 1 divided by 8 would tell me that that's 0.125. That is correct. It's 0.125 inches. But it's still in inches. It's not in feet yet. In order to put it in feet, I have to divide it by 12. And then I recognize it. I say, oh, that's right. Anytime I put something at a 1% grade, I'm always putting that at 1/8 of an inch per foot. So a 1% grade is 1/8 of an inch per foot. Easy enough. All right, the next thing I want you to do is look at this little exercise here. it says convert 0.31 of a foot back to a ruler measurement. Okay, well, now think about this. And always go back to the whole units. For me, it makes it easier for me. I always think real quick, 1 foot. Now, how would I convert that to inches mathematically? Well, multiply by 12. Well, I'm going to multiply 0.31 feet by 12. It's feet times 12. That would tell me that 0.31 of a foot is actually 3.72 inches. So now I could tell one of my men, or women, hey, cut me a board 0.72 inches. They're not going to understand what you mean, so you have to convert it for them. 0.72 of an inch is simply part of an inch. What part of an inch is it? Well, how far do you want to break your math down? Do you want to go just to 1/8 of an inch, 1/16 of an inch, 32nd, 64ths, what? Most of us in construction, we're only concerned with the 1/16ths. That's what our standard tape is broken into. So I want to know what 1/16th of an inch increment is 0.72. Well, if I multiply that by 16, of course, I want it in units of 16, and that'll tell me it's 11.52. Well, think about it. You slide your fingernail over on a rule, on a tape measure, you're going to be at 11.52 sixteenths. So you're going to be right at, a high end of 11 sixteenths and right next to 12 sixteenths, 3/4. So in math, 0.5 and above, we round it up, and 0.4 and below, we round down. That's the way we were taught. So I'm going to say that it's 12 sixteenths. And I know 12 sixteenths is simply reduced down to 3/4. So there you have your answer. It's 3, and 3/4 of an inch. All right, so feet times 12, and then a decimal equivalent of an inch times 16. We'll put it in 1/16 of an inch. So this is one of the little lessons I want to put in here for you. Take a 13-foot 2-inch pipe and cut that into 3 equal lengths. What would the length of each piece be? Well, now typically I'm going to give you just a couple of seconds to come in here and calculate this yourself to see how it's actually done. Okay, but since I'm recording this class for you, if you want to give it a shot yourself, go ahead and reach up and pause the show and then work it yourself and then start the show up again. Okay, so I'm going to go ahead and work this for us. And I know you could do it. You probably already did it. So 13-foot 2-inch. Now I cut the 2-inch and went ahead and converted it. I said 2 inches divided by 12 is 0.16 or 0.17 or 0.166, whatever you want to leave it. I want to come back here and show you the difference here. What difference does it really make? Where you round the numbers. The test writer said you can truncate at 2 or you can carry it out to 10. It's not going to make a difference one way or another to you. So whatever you feel comfortable with. So I took the 13.16 feet and simply divided that by 3 equal pieces. That tells me that I need 3 pieces that are 4.38 feet each. Now, once again, I know 4 is 4 feet. What I need to figure out is, what is this 0.38 of a foot, this part of a foot? What part of a foot? Well, again, 1 foot times 12, so 0.38 times 12 is 4.56 inches. Well, now I'm smart enough to look at that and say, well, 0.56 of an inch is part of an inch. Now I'm going to figure out what part of an inch it is, but, I know 0.5 is half an inch just by looking at it. I know 0.75 is 3/4 of an inch. I know 0.25 is 1/4 of an inch. So whatever answer it is, I know it's got to be more than a half an inch. Well, when I look up, there's only one that is, and that's answer C. 4 feet 4, see, it's 4 whole inches, so I know it's not A or D, and I know it's more than a half an inch, so 5/8. So I could just answer C right now and go on, but I'm not going to. I'm going to say 0.56 is part of an inch. What part of an inch multiplied by 16, and that's 8.96. Well, again, 0.5 and above round up, 0.4 and below round down, that needs to be a whole number. So I'm going to say it's 9/16. So now I'll look up to answer C, and answer C is a 1/16 of an inch more than that. It's 5/8. Yeah, if you would have used 0.166, you would have come up with 5/8. If you would have used 0.17, you would have came up with 11/16. So either way, you're within a 1/16 of an inch increment. Nowhere in the test are they ever going to hold you within a 1/16 of an inch. I mean, think how tight that is. Okay, so they're not going to do it to you. Well, the next thing that's exciting that all of us want to look at is all the formulas and constants that we may have to deal with during the examination. Now, keep in mind, there's hundreds, thousands of constants out there. We're only looking at the ones that pertain to us for the test, and then the ones we use constantly in the construction. So here they are. Let me get my pen out here. There's 144 square inches in a square foot. And I'll bet most of you know that. You know, a square foot is simply a 12 inch by 12 inch. Okay, it's a little square. Just like that. I mean, my gosh, that's drawn to scale almost. But it's 144, 12 times 12. 9 square feet in a square yard, a 3 foot by 3 foot. In roofing, 100 square feet is always considered one square on a roof. So every 100 square feet of area is one square, okay, in roofing. Here's one that you think about all the time and talk about to your buddies. There's 43,560 square feet in 1 acre. So for every 43,600 feet, I know that's 1 acre of area, okay? Some have always wondered about, and mystery of life is now solved. The other one is cubic or volume down there. Now remember, this is a 12 by 12 is 144. Put a third dimension to that. And you can call the third dimension a depth, height, or a thickness. It really doesn't matter. It's a third dimension. So I have a shape that's 12 by 12 by 12. And if you did the math there, 12 times 12 times 12 is 1,728. There's 1,728 cubic inches per cubic foot. Okay? Just like there's 27 cubic feet per cubic yard. Okay? Now remember, it's 3 by 3 by 3, 27. A cubic foot will hold 7.48 gallons of water. And I know a lot of people question that and think about it, so that's what it is. Holds 7.48. A gallon of water weighs 8.34 pounds. It's a constant. A cubic foot of water, remember that's 7.48 gallons or 7.5 gallons. That's 62.4 pounds or 62.5. Whatever's easy to remember for you. Okay. It actually comes out to be 62.4, but it's easy to remember 62.5, so it doesn't matter. There's 231 cubic inches in a gallon. Now, that's just a constant. Now, typically, we only use that when we talk about painting. So, for most of you, you're not going to be doing too much painting, but, you know, I put it in there anyway. It's a good one to know. One down at the bottom is trading on us to you, but I think most of us know it. 2,000 pounds is equal to a ton. Okay, to every 2,000 pounds is 1 ton. A meter, think about that. Little bit over 3 foot 3 inches. Remember, 3 inches is 0.25 of a foot. So a meter is 3.28. So just a little bit over 3 foot 3 inches. A little bit more. Okay, a mile is 5,280 feet. That's a linear measurement. So if you walk, 5,280 feet, you're going to end up walking 1 mile. That's all it is. The next part of it is estimating with geometric shapes. Now, again, as I go through these, if you need to stop and look at it, reach up and hit the pause button on your computer, on your screen. That way you can pause and look at it as long as you want. For the most part, I'm just going to go through these real quick and just, hit the topic and go on. Okay, I'm not going to spend a lot of time on these. So, a square rectangular shape, length times its width. On any area calculation, once you have 2 dimensions, that is an area calculation. Square feet, square inches, square meters, whatever you want. Now, if you multiply a shape, any shape that you have an area of, and multiply it by the 3rd dimension, depth, height, or thickness, you're going to get cubic or volume. So length in feet times width in feet times depth in feet is cubic feet. Okay, it's volume. The second easiest shape is a trapezoid. A trapezoid is simply a shape with 2 parallel sides. Now think about it. If they have parallel sides, that means they have a common width. So anytime you want to average 2 dimensions, you add them together and divide them in half. So I would take the first length and add it to the second length, and then divide that in half, and that would give me a centerline length, or an average length, right down the middle. Okay. Well, if that's the average length, it has a common width to it, so multiplied by its width, and there you have an area. Now, think about this shape. What's going on here? The area that's sticking out right here, well, that's the same area that would fit in right there. Same over here. The area that's out here would be the same area that would fit right there. All I did was take an odd shape and square it up on the ends. All right. Now, once I know what the area of the shape is, square feet, square inches, square meters, multiply that by a 3rd dimension, and that's going to give me cubic or volume. Okay, cubic or volume. So that's a trapezoid. The hardest thing about a trapezoid is the name. Okay, all we're doing is averaging a couple of lengths there. All right, circles. And I even put the fancy little pi symbol in there for you. Sometimes that's hard to find, believe it or not. So here's a formula for us. Pi r squared and pi d. Okay, let me think about what that is. The symbol of pi, okay, represents 3.14 in decimal form. Now, you can carry pi to as many decimal points as you choose. I mean, the last I heard, they were at the 314th trillionth decimal point, and they're still rolling it. So as many as you want. 3.14 is good enough for me. Now, a circle, the widest point of a circle is called the diameter. Half the diameter is called the radius. So the diameter is simply twice the radius. Yeah, same thing. So if I want to know what the area of this is, 2-dimensional. So if I'm looking at this as a round patio slab, okay, how many square feet of carpet area on it? How many square feet of painted area is there? 2-dimensional. How many wall area, carpet area? Okay, so it's pi r squared, pi times radius times radius. So if the radius is, or if the diameter is 20 feet, the radius would be half of that, so the radius would only be 10 feet. And the formula would be pi times 10 times 10. And that would give me the area of that circle. Okay, 2-dimensional. Multiplied by a length, and you have volume. Now, this one is pi d. Pi times its diameter is going to give me that outside circumference, the outside perimeter of the pipe, the length of the floorboards around your slab. Okay, what's that dimension? It's pi times its diameter, so 3.14 times 20. All right, so pi d and pi r squared are the only ones we deal with. So pi r squared, pi times radius, is going to give us the area of a circular shape. Multiply the area times the depth. How thick are you going to pour that little round patio slab? 3 inches, 4 inches thick. But before I even do that, I got to form it up. What's the linear feet of floorboards I would need? Well, that would be pi d, pi times its diameter. And that would give me the outside perimeter or circumference. Yeah, circles are cool. So anyway, calculate the cubic feet of concrete to pour 30 bollards that are 6 inches inside diameter and 8 feet in length. Well, gosh dang it. I know it's a circle. I know there's 30 of them, and I know it's 8 feet. And there's a bollard. See, they put them in front of the McDonald's window there. Now, here's how smart I am. When I pulled through I couldn't take the picture when I was on the other side. I had to pull through the window, stop, and get out of my truck to take a picture of the bollards. It's like, well, I could have did it the other way. It'd been a lot easier, but nothing's ever easy for me. So that's a bollard. It's a steel sleeve filled with concrete, so they don't take out the windows at McDonald's or the gas pumps, or they don't run off into the water at a dock. Okay, so bollards. So it says calculate the cubic feet of concrete to pour 30 of these, 30 bollards that are inside diameter of 6 inch inside diameter and 8 feet in length. Well, now think about that. Even if I don't know what it is, I know it's got a 6, and that's a perfect circle, guys. Geez. If that is 6 inches inside diameter, now that's just the top of the bollard that you're looking at, the top of the post. All right, I know half of the diameter, though, is the radius. So the radius there would be 3 inches if this was drawn anywhere close to scale. Okay, it's 3 inches here. So I need to calculate the area of this first. Now remember, we said the area of a circle is pi r squared. Remember, cakes are round, pies are square. So pi times the radius times the radius. I know the radius is 3 inches, and I can convert that to feet by taking 3 inches and dividing it by 12, and that gives me 0.25 of a foot. Now I can plug it into my formula. The reason I did that and didn't leave it in inches is because the answer wants to know in cubic feet. Now the reality of it is, do it any way you want. Leave it in inches. Just remember to convert it back to feet. So as long as you're comfortable with converting numbers, remember there's 144 square inches in a square foot, 1,728 cubic inches in a cubic foot. So remember your conversions, and sure, leave it in inches. But I did it in feet. Okay. Now everything else is in feet. So pi times the radius of 0.25 times the radius of 0.25, that's going to give me the area of this. And that's this area right here. That's 0.196 square feet. So I know the square footage of the area. Multiply that by a third dimension. The question told me it was 8 feet in length. So I know one of these bollards is going to require 1.57 cubic feet of concrete for me to pour it. Okay, I don't have one. I have 30. So I'm going to go ahead and multiply that by 30. And that'll tell me I have 47.1 or 47 cubic feet. This is what I need. Now, notice they put it in cubic feet. Most of us, we don't purchase concrete in cubic feet. We purchase it in cubic yards. So we're always thinking cubic yards. You talk to me about dirt or concrete, and I'm always thinking about cubic yards. I'm never thinking about cubic feet. I'll order concrete in cubic yards. So it's real easy to look at that and 47 cubic feet divided by 27, that's 1.74. One of the answers is going to match, and unfortunately it'll be the wrong answer, but it's one of the answers. So go ahead and slow down and stop and think about what you're doing before you do it. Okay? Sometimes when you get into the mathematics, just slow down just a little bit and answer what they're asking, not what you think they're asking. And notice I put some of the numbers down there. Now notice that answer A is if you missed and only calculated one of them, which some people will. They'll, when they come to that number, they notice that number matches one of the numbers on the test, and they'll stop. They won't even finish it. Others will, without thinking, divide it by 27, and all they see is, hey, the answer on their calculator matches answer B. They must be right. And then there is 1.74, but the question wants to know how many cubic feet. So answer C is just a mathematical calculation, and then the correct answer is answer D. All right, now here's one. Geez, guys, this will save you a lot of time if you do a lot of estimating, or if you're out on a job site and you're trying to figure out the little outside areas. And it drives us bad, but most of the time, most of us just square it off and, guesstimate. We don't accurately estimate, which reality is close enough, okay? But for test world, we got to be exact, unfortunately. So let's look at these formulas. They're not that bad, and they're nice when you understand them. This is a quarter of a circle, And if I'd say, well, how many square feet is there? I'd say, well, I could just go pi r squared and divide it by 4. Pi times radius divided by 4 is a quarter of a circle. Yes, that is it. Just pi times the radius again. That would give me area of a complete circle. Divide that answer by 4, a quarter, and that's going to give me the area there. Well, this part of the formula, let's think about it. Most people never even talked about it or took 2 seconds to even think about it. But radius squared, that's taking a number and multiplying a number by itself. In other words, if this is the radius from here to here, that's 10 foot. Well, if I said, well, if the radius is 10, I'm going to go 10 by 10. Well, that's 10 foot by 10 foot. That's giving me, think about it, the area of a square. Every single time. Any number of times itself is the area of a square. That's all this is doing, is giving me area of a square. Okay. So the radius times the radius. That's what I just did. Well, what's left is pi divided by 4. What's a quarter of pi? 3.14 divided by 4, a quarter. That's 0.785. It's a quarter of pi. So all I would have to do here, since that's telling me that the inside area of a circle is always 78.5% the area of a circle. Always, at a constant. It's a quarter of pi. It has to be. Okay, so 78.5% or 0.785 of the area of a circle is 1/4 of it. That would always give me this inside area. Well, if that works, and we know it works, then what about this outside area over here? Okay, well, if the inside area is 0.785 and the outside area is 0.215, then all I would have to do is go radius squared times 0.215. And that would tell me what this area is. The outside area, this little flare here, at a constant, it's always 21.5% the area of a square at a constant. So that's always 21.5 square feet, or 21%. I'll get it here right in a minute, guys. That's 21.5% the area of a square. So if the radius is 10 feet there, I would go 10 by 10. That's 100. Then I'd multiply by 0.215. And that would tell me that's 21.5 square feet. So pi squared divided by 4 will give me a quarter of a circle, or 0.785 times the radius squared will give me a quarter of a circle. Now the 0.215 times radius squared is always going to give me this outside flare. And that's what we're trying to calculate when we're out in the field. And we're trying, how do I calculate this little flare? Well, that's how you do it. Now, again, most of us in estimating, we just square it up and, close enough. But that's the accurate way to do it. Okay. All right, now this one is for triangles. Now the formula used to obtain area and volume. So area, now look at this, base times the height divided in half, or 0.5 times the base times the height. Now remember, just a very quick lesson here, reciprocal numbers. If you can divide by a number, you can multiply by the number's reciprocal. Now, don't study on this too much, but listen, if I can divide by 2, I want to know what the reciprocal of 2 is. So if I can divide by 2, what number can I multiply by? 1 divided by 2, and that tells me then the reciprocal of 2 would be 0.5. It is, which 0.5 simply means half, 1 divided by 2. Okay. So you can take in the base times the height divided in half, or half the base times the height. It's most of us, it's easier to multiply than it is to divide. But listen, it really doesn't matter. You get the same answer. So it's whatever you feel more comfortable with. Now we look at what I did. Let me explain that. I drew in 3 blue rectangular shapes. Now the visual that I was hoping for is you could see the red area, the red triangle that I drew inside of each one of those is simply half of the total area. Okay, no matter which way you look at it. And it is. So it's half the base times its height. Now, once again, we already talked about this and said, well, the area of the shape, square feet, square inches, square meters, multiply it by a third dimension of depth, height, or thickness. And now you have a cubic or volume measurement. Cubic or volume. Here we have the Florida Code Discussion Forum. My Florida Code is a public code discussion forum for Florida Code construction licensing issues, downloads, and links. Okay, myfloridacode.com. Now, myflorida.com is a site where you can go and post questions. Okay, and you're going to get some responses. There's a lot of people monitoring it. There's, we have architects, engineers, accountants, teachers, contractors, superintendents, building officials, other code officials, board members, a little bit of everyone who monitors it. Now, let me give you just a little bit of a warning. When you put up a question, you're going to get some answers. Now, unfortunately, it's not always the answers that we're looking for, but you'll get an answer, and a lot of times when you see the different people, when you look at their focus, where's it coming from, what point of view, it'll change a little bit, so it'll give you a better appreciation of your code officials and why that they interpret things the way they do. It is confusing to some of us, to all of us, let's face it. Okay. This concludes our learning module. Please click on the Return to Course link at the bottom of the screen to return to the course menu. You may be required to complete the quiz at the end of this module or at the end of a bundle you're working in. Thank you for choosing the Contractors Institute to complete your continuing education hours. If you have any questions, please give us a call or email. Okay, again, my name is Richard Elsey. If you have any feedback about this module, feel free to contact me. Okay, include email and address.